Hello everyone. Today I am going to discuss about LeetCode problem number 1 to sum. Let us try to understand the problem statement first. Here we are given an array of integers nums and an integer target. Return indices of the two numbers such that they add up to target. Okay, you may assume that each input would have exactly one solution and you may not use the same element twice. Okay, that's great. You can return the answer in any order. Okay, so we are given an example here, nums 2, 7, 11, 15 and target is 9. So if we add up 2 and 7, which is 9. Okay, and index of 2 is 0, index of 7 is 1. That's why output is 0 and 1. Similarly, example 2, 3, 2, 4, target 6. 2 plus 4 equals 6. Index of 2 is 1, index of 4 is 2. So this is what we need to return. Here I have another example 2, 3, 5, 7, 15, 21, right? To solve this we can use two loop. One of them is outer loop, other one is inner loop, right? So outer loop is I, which is position of 2, index 0, and inner loop is position of I plus 1, which is here, right? So we can sum up 2 plus 3, which is 5, which is not equal to target 22. Then we can increase the j, which is 5 here, right? And 2 plus 5, so it is not 22. Similarly, 2 plus 7, 2 plus 15, 2 plus 21, none of them has target 22, right? So then we can increase outer loop position here, so I equal 1, and then j equal I plus 1, which is here, right? Then 3 plus 5 not equal 22, 3 plus 7 not equal 22, 3 plus 15, 3 plus 21 not equal 22, right? Then we can increase outer loop here, I equal now 2, and then j equal 3, I plus 1, which is 3, right? 5 plus 7, 5 plus 15, 5 plus 21, so there is no target 22. Then we can increase here I equal 3 and j equal I plus 1, which is 4. So 7 plus 15, which is 22, right? So this is our solution, 7 and 15, and so output is gonna be 3 and 4, right? So this is our solution. So in this approach I had to use two loop, one is outer loop, one is inner loop, right? So that's why time complexity is gonna be B go. So I had to run outer loop n times. N is the number of the elements in the array, so n times, right? So n into inner loop. In the inner loop I had to run n times, which is another n, which is big O n square, and a space complexity, right? So for a space complexity we did not use any additional array or anything, right? So that's why it is constant, so we can say it is big O 1. Okay, so we can solve this in the LeetCode. So let's move into the LeetCode. I'm going to use Java code. You can use any language as you prefer. And we are given numbers, integer, array as a parameter, and also target, right? So what we can do, we need to use for loop. This is for outer loop. I equal 0, right? I less than length. So I can use one variable here to get the length, because I need to use this length twice. I plus plus for integer j equal I plus 1, j less than length j plus plus. So this is my inner loop. So here what we can do, we can sum num I with num j, right? If that is equal to our target, then we can return new integer array of I and j, because we need to return the indices, right? Okay, and then and it says we should have exactly one solution. That means the input should have exactly one solution. If nothing is there, we should return null. Okay, let's run this and accepted all cases. We can also add additional test case, right? So I have one test case here, 2, 3, 5, 7, 15, 21. Let's add that one. 2, 3, 5, 7, 15, 21, right? And target is 22. Let's run this. Accepted, that also accepted. So 3, 4, right? Yeah, 3 and 4. So what we can do, we can submit, and my solution rank is here, and it took 37 millisecond, right? But there are a lot better solutions here. If you see, a lot better solutions are there. So how can we improve that, right? So that is my second part. How can we improve that solution into, like, so this is now n square. How can we improve that in terms of time complexity? Well, instead of running this inner loop, right, we can use HashMap. So what we can do, let's probably I should remove this, maybe. Okay, or put it aside here. So I'm gonna use for this one, I'm gonna use this space. So I'm gonna use HashMap. In HashMap, we can add or retrieve the value in constant time. Okay, so we can put an element in HashMap in constant time. We can also get that element in constant time, which is big O1, right? So that is the extra advantage. So HashMap has two parts. One is the key, other one is the value. Okay, how do we use the HashMap here? Exactly, we wanna keep the number and its associated indexes. Okay, So what we can do, at first the hash map is empty, right? It doesn't have anything. So we can start, still we need this outer loop, right? Still we need to use this outer loop in our hash map. So our I is here 0, so let's say 22 minus 2, which is 20. So we can check here if hash map contains 20, right? That means 20 is there, but 20 is not existed in this hash map so far, right? So if it is not existed, that means we should store 2 here with the value of 0. 0 is the index, this one. Okay, similarly 3. So 22 minus 3, which is 19. Is it existed in this hash map? No. So we can import, we can add the 3 with index 1. Same as 5. So 22 minus 5, which is 17. Is it existed here? No. So we should add 5 here with index 2 as a value. Then 7. 22 minus 7, which is 15, right? 15 existed here in the hash maps so far? No. So we should add that here with the value is 3. Now 15. 22 minus 15, which is 7. And if the, now we can check if 7 is existed in the hash map. Yes, 7 is existed. That means we got the solution, right? So 7 is existed and that was visited before 15, right? So 7 was visited before 15. So this is one of the number we have. So what is that index for that? What is the value for that? 3. That means 3 is I, and the current I here is 15 and index is 4, so which is 4, right? So in this approach we simply visited once per every element, right? We did not need to run another loop to revisit every element again. So that's why it is linear time. So that's why the time complexity is gonna be big O n, because we visited once every element here. So at max we may need to visit every element here, which is n. So that's why time complexity is big O n, and space complexity is gonna be, if you see, we had to use the hash map here, right? The hash map, and in the hash map we had to store all the elements from the array in the hash map, right? Also indexes. So it can be it is actually, we can say n plus n, because n is the number of the elements of the array and also number of the elements of the indexes, right? So n plus n, which is actually big O 2n, and we can ignore the constant. That's why we can say a space complexity is also big O n. So this is the trade-off here. Are we gonna use n square, or are we gonna use big O n and also consider a space complexity here, right? So this is a lot way better solution than the brute force this n square solution. Okay, now let's go into the solution, LeetCode, and solve the, and let's try to solve it here. Okay, hash map. To use the hash map we have to use hash map, then we can use integer, because we need to use 2 integer here, right? Integer, and we can give it a name as a map, new hash map, integer okay. Then we need to use the loop as we discussed in the example. We still need that outer loop, which is only one loop, and we need to run through the length, right, I plus plus. So here we can say reminder, or we can say remaining. Actually remaining, we can give it a variable name remaining, make it convert to integer, and that is gonna be target minus nums I. Yeah, okay. If map contains key, right, that remaining, so it's gonna be remaining. Oops. Remaining, okay. So if it contains in the map, then we got the solution, which is new integer array of we can get it from map remaining and the current index I. Okay, if it is not in the HashMap, then we can add in the HashMap, put the numbers with its index, which is this one, right? If there is no solution at all, right, we can return now. Okay, we can try to run and see is there any error or something. Okay, accepted. Even our fourth case is also accepted here, right? And we can submit the solution. The previously our solution was here, like the runtime was 37. Now let's see if it is gonna improve that. 2 milliseconds. See, a lot better. It was like 37 milliseconds. Now it is 2 milliseconds, right? And we beats like 97.94%, which is way more better than the previous solution. Okay, so I hope you enjoyed this solution. If you still have any question or any doubt, you can write in the comment. I will try to. Right? Thank you so much.